All right, so this is part 2 of section 4.5, which is graphing trigonometric functions. So if you have not watched the live lesson from Wednesday introducing these, then you need to do that first. Otherwise, this isn't going to make a ton of sense. So the new part about what we're going to kind of do today with this is we're going to start looking when we have what's called a vertical shift. So we've already talked about doing amplitude, period, and period. We're going to move on to vertical shift, and then we'll also talk about something called phase shift. So a couple things. One of the first things we'll do is we'll always do the amplitude, and that's always the absolute value of the number in front of the sine or cosine. So in this case, that's this 2. So the absolute value of 2 is 2. Now, that's the distance from your midline up and then down to get to your high and low values. And so the midline is going to be important, but the midline is going to change a little bit. So yesterday, the midline was always on this x-axis or theta axis. In this case, that's going to change a little bit. So from there, you go up 2 and down 2, depending on where your midline is. And that is important, especially when your numbers in front of here are negative. The period of the function, if it's in degrees, we do 360 divided by what's called the b. So in this case, we don't have anything to hint at whether it's degrees or radians. It doesn't tell me, so we'll assume that. And then this is where we're going to kind of talk about, we're going to use this. That's our b value, so I divide it by 3. So then that gives me 120, which means I'm going to, since I don't have what's called a phase shift yet, I'm going to start here at 0, and I'm going to end over here at 120. And then after that, they're going to repeat. So I could keep on going up, and it would repeat in that regard. Now, this time we have what's called a vertical shift. So that vertical shift is this plus 1, and that tells me it's going to go up 1 unit. Now, if you say that the vertical shift is plus 1, that's fine as long as you know. So here's what that means. Got a couple little things that this is going to go up 1. So what happens is my midline is at this positive 1. Now your high and low values, remember your amplitude here was 2. So starting at my midline of 1, I'm going to go up 1, 2. And then I'm going to go to my midline and go down 1, 2. Notice I'm counting this axis. I'm going 1, 2. So this is how it's going to be kind of constrained between the top and the low. The next thing we have to do is we have to go and do what we did before, where we need to go halfway. So halfway between 0 and 120 would be 60. Remember, if you're not sure, add them up. So 0 plus 120 is 120. 120 divided by 2, that's 60. You're basically taking the average of those. And so that gives me 60 degrees. Then go halfway between this and that. Well, 0 plus 60 is 60. 60 divided by 2 is 30. And some people say, well, these are kind of going up by 30 now, right? So this has to be 90. Yeah, you can figure that out. Sometimes it's obvious, sometimes it's not. But if I was doing it the way I was doing it before, what's halfway between 60 and 120? Well, you'd add up 60 plus 120, that's 180. 180 divided by 2 is that 90 like we're talking about. And then now we're going to go to the actual graph. So we learned that a sine graph starts right at the midline. So I'm going to start this midline. So I'm making a dot right here first. A cosine starts at one of the top or the bottom, depending where the amplitudes are. Now, a positive sine will start the midline and go up, cross the midline, down, cross the midline. If it's a negative sign, it would go down first. But since this is a positive 2 here, it's going to start here. It's going to go up to the first dash mark high value. It's going to go to the second dash mark, in this case, right at the midline. Then it's going to go to the next dash line at the lowest, and then back to the midline. And remember, we're trying to make this as curved as we can. So it's going to kind of curve like that, start changing, bottom out, and then go up to there-ish. So it's similar to what we did on the live lesson, but this graph, that graph is just being moved up 1 unit. Okay, this one's going to be in radians, so a little bit different, but pretty similar. So first thing, we'll find the amplitude. That's the absolute value of the number in front. Now, if I look here, there's really a negative 1 there. So really, I'm taking that negative 1, and so then that gives me a positive 1. So that means from the midline, you go up 1 and midline down 1, and that'll kind of give you your high and low values. And then I'm going to do my period. And this, guys, because it's in radians, it specifically tells me I'm doing 2 pi, and then I divide that by whatever b value is, which in this case is 2. So 2 pi divided by 2, that gives me just pi. So that means I'm starting here at 0. I'll start here at 0, and I'm going to end at pi radians. And then I have my vertical shift. In this case, that's this -4 here. That means it's going to go down 4. So my midline, based upon this, my midline kind of drops down. So it was here, and I'll make a couple of dash marks. So my midline is now going down 1, 2, 3, 4. So some people say, well, whatever that number out, that D value, that number out here, that's where my midline is. I agree. Right there at -4 is where it's going to start. Then, since my amplitude was 1, notice that negative is going to tell me more about the graph. That 1 means I'm going to go up 1. That's my high value. The last example, we went up 2. And then I go down 2. So this is kind of how it's constrained. Now we're going to find these values. So if I go halfway between 0 and pi, so this is where people struggle a little bit. So remember, if you want to average them out, you're going to say, add them up. So I'm taking these and then divide by 2. Well, that would give you pi over 2. Okay, so then this is pi over 2. Okay, what's halfway between 0 and pi over 2? So same thing, 0 plus pi over 2 divided by 2. So then that would give me 0 plus pi over 2. That's pi over 2 divided by 2. Now, we can do a keep it, change it, flip it here, but one thing that happens always is when you take a fraction and you divide by a number, you're just multiplying those numbers. So that's really the same thing as pi over 4. So then this is pi over 4. And then the last one, it's a little bit more difficult because we got to do a couple of things. So first thing I need to do is I need to add up those two numbers. So I'm saying what's halfway between pi over 2 and pi. So add them up. Then divide that whole thing by 2. Now, I can't add these up right now because I don't have a common denominator. But I can get one. I can get this to be a 2. So I'll multiply top and bottom by 2. So I'll have pi over 2 plus 2 pi over 2. And then that whole thing is divided by 2. So there's a lot of numbers here. It's really easy to get messed up. So this whole thing is divided by 2. So now I need to add these up. Well, I have that common denominator of 2. Pi plus 2 pi, that's 3 pi. And then I've got a fraction divided by a number, which means I just have to multiply these guys together to get there. So then that's going to give me 3 pi, and then 2 times 2 is 4. So I get 3 pi over 4. So that definitely gets a little messy. So 3 pi over 4. Now we're ready to graph this one. So going from here to in order to graph this one, a cosine value does not start at the amplitude or at its midline. It either starts at the high or low values. Since it's negative, it's going to start at its low value. And then it's going to go to the next dash mark and hit the midline, the next dash mark and hit the high value, the next dash mark and hit the midline, and then the next dash mark and hit the low value again. So this thing's going to be kind of curved again as best we can. Looks something like that. So it's kind of flatter than the last one was, but the last one had a bigger amplitude, so it kind of pulled it more vertically in that regard.